Hi, Transitional Math students. Mrs. Robinson here to practice benchmark chapter 5 with you. Let's start with the first one. Indicate the answer choice that best completes a statement or answers the question. So here we're looking for which fraction represents the ratio 6 cups to 5 quarts in simplest form. Well, first of all, you need to know how many cups are in a quart. So if you want to look that up, I'll just tell you right here. There are 4 cups, and that equals 1 quart. So if I want a ratio of cups to quarts in simplest form, I need these to be in the same units. So I'm going to change quarts to cups. That's easiest to do. 4 quarts is 1 cup. So I need to do 4 5 times to get 5 quarts. So I'm going to go 4 times 5, which will give me 20. There are 20 cups in 5 quarts. Since there are 4 cups in 1 quart, there's 20 cups in 5 quarts. So I'm going to do 6 cups to 20 cups. And if I reduce this, let's see, 2 goes into 6 3 times, and 2 goes into 20 10 times. 2 goes into both of these numbers. It can reduce 3 to 10, and it would be C. All right, on to the next one. Let's see, which fraction represents the ratio 6 feet to 3 yards? Similar problem. I need this to be in the same unit, so I'm going to change yards to feet. I'm going to change the bigger one to the smaller one. I know there's 3 feet in 1 yard. So if there's 3 feet in 1 yard and I need 3 yards, I need to multiply 3 by 3, and that will give me 9. There are 9 feet in 3 yards. So I'm going to go 6 feet to 9 feet. There's my ratio. And these are both divisible by 3. So 3 divides into 6 2 times, and 3 divides into 9 3 times. This would be 2/3, and the answer would be C. A little hint, careful here. It said feet to yards, and it went 6 to, we changed these to feet also, 6 to 9. Don't get confused and do it the other way. This would be if I went 9 to 6. So don't let that confuse you. Make sure you do it in the order they give it to you. All right, a train travels 325 miles every 5 hours. What is the unit rate of the train? So I'm just going to do this. 325 miles per hour, and that would be per 5 hours. I want this to be per 1 hour to get my unit rate. So I'm going to divide top and bottom by 5, or just do 325 and divide it by 5. If I do 325 divided by 5, I'm going to get 65. So this would be 65 miles per every 1 hour. 65 miles per hour. And there's your unit rate. Okay, number 4 says which rate has the same unit rate as 8 books in 12 weeks? Now, if I did 8 books to 12 weeks, and I want to find a unit rate, I'm going to divide both the top and bottom, or divide this by 12. And it's going to be less than 1 book a week. So if I take 8 and divide it by 12, I'm going to get 0.6. Okay, if I reduce this fraction, it's actually 4 goes into 8 2 times, and 4 goes into 12 3 times. So it's 2/3 of a book in 1 week is what it would come down to. 2/3 of a book in 1 week, or 0.66 of a book in 1 week. So which one of these is that same ratio? 2 books in a week? No, that's not 2/3 of a book in a week. 5 books in 7 weeks? Well, is 5 out of 7 the same ratio as 2/3? Just divide it on a calculator if you're not sure. It's not. It's 0.7. So it's not that one. How about 6 books in 15 weeks? Go ahead and reduce this fraction. 3 goes into 6 2 times. 3 goes into 15 5 times. 2/5. That's not quite 2/3 of a book in a week. It's 0.4. How about 3 books in 4.5 weeks? That looks like it might work. Let's see what 3 divided by 4.5 is. It's 0.66. So here I have it. This is the same unit rate as 8 books in 12 weeks. So just divide these out and see if you get the same ratio. 0.66 was my ratio. So that's all you have to do there. All right, an athlete runs 5 miles in 1 1/4 hours. If the distance is proportional to the time spent running, which of the following is not an equivalent rate? So one of these is not. Well, let's see what the equivalent rate would be. 5 miles divided by 1 1/4 hours. So 1 1/4 hours, okay? If you want to change this, you can change that to a decimal. 1 divided by 4 is 0.25. So this would be 5 miles over 1.25 hours. Do the ratio on this on a calculator. 5 divided by 1.25, that's going to give you 4. This will be 4 miles in 1 hour, 4 miles per hour. So what about this? 3 miles to 3/4 of an hour. Does that give you the same ratio? Well, go ahead and divide this out. Take 3 and divide it by 3/4. You could keep the first, flip the second, and change to multiply. Keep the first, flip the second, change the divide to multiply. And when I do this, 3 is the same as 3/1. The 3's divide out and I'm left with 4 miles per hour. So this one checks out. It is 4 miles per hour. Check this one. What about this ratio? 2 divided by 1/4, or 2 miles per 1/4 of an hour. Go ahead and do the math on this one. Do the same thing down here. Keep the first, flip the second, 4/1, and change the divide to multiply. 2 is the same as 2/1. Well, 2 times 4 is 8. This is 8 miles per hour. This one is too fast. It's not this one. You can go ahead and check these two. This last one's easy. It's already done for you. 4 miles per 1 hour. So this one checks out. Check this one. 7 miles per 1 3/4 hours. Well, 3 divided by 4 is 0.75. And you can do that on a calculator and just check it out. So this would be 7 miles divided by 1.75 hours. Do the math on that. 7 divided by 1.75. If I do that on a calculator, I'm going to get 4 miles per hour. So that confirmed it. This is right. This is right. It's just B. B is the only one that doesn't work. Okay, number 6 wants you to find equivalent rate to 72 kilometers per hour. So if I have 72 kilometers per hour, km for kilometers per hour, and these are all in miles per hour, I need to change miles to kilometers in order to figure out which rate's equivalent. So how many kilometers are in a mile? Okay, so if you look in your book on page 201, there's a bunch of rates there that you can use. And you'll see 1 mile is equal to 1.609 kilometers. So a kilometer is, think of it like a little more than a mile, okay? 1 mile is 1.609 kilometers. So like a kilometer and a half is a mile. So let's go ahead and figure out 72 kilometers. If we have this ratio of 100, you can write them like this, 160 or 116 miles per hour. And we want to know kilometers per hour. So what I'm going to do is I'm going to set up a little ratio here. I want my miles to fall out. So I know 1 mile is 1.609 kilometers. I'm going to put 1 mile here on the bottom. And I'm going to put 1.609 on the top. And hold on, close that out. And here we go. Sorry. On the top, so that I can see the miles will cancel out. And it's going to leave me at 116 times 1.609 kilometers. So kilometers will be on the top and hours will be on the bottom. And I'll go 116 times 1.609 on my calculator. And that's going to give me 186.644. And that will be kilometers per hour. Well, this is not 72, so I know it's not this one. Check 54. Go 54 miles per hour times that by 1.609 kilometers per mile. Okay, this is these fall out, so I'm just going to go 54 times 1.609. That gives me 86, so I know it's not this, 86.6 kilometers per hour. It's not that one, it's not that one. Try 45. It's getting closer. 45 miles over 1 hour, and we know it's 1.609 0.09 kilometers for every 1 mile. So the miles will cancel, and I'm going to go 45 times 1.609, and that's going to give me 72.405, or approximately 72. That will be kilometers, because the miles fell out. It's kilometers per hour. So it's not exactly, but close enough. So this is the equivalent to 72 kilometers per hour. All right, on to the next. Okay, which measure is the correct metric approximation for feet? Go ahead and look on page 201 for those conversions, and you can look up those conversions for the test. I don't mind if you look up conversions, okay? So I know how many feet are in a meter. That's what I need to know. And that I can see 1 meter is approximately, and this is a rounded, it is 3.279 feet. And that's approximately 1 meter. So, which is approximately 7 feet? Let's go ahead and check this out. If I do 2.1 meters, and I'm going to want to get the meters to fall out, so I'm going to come over here and multiply by 3.279 feet is 1 meter. So I'm going to multiply it like that, and the meters will fall out, and I will be left with 3.279 times 2.1. Do that on a calculator, and it is approximately 6.8859. Now that is feet, and that's pretty close to 7. 4.3 might be too big. This is way 21.3. If I multiply 3.297 times 2.1 and I get almost 7, if I multiply 2.1 times 21.3, that's going to be way too big. Okay. Or sorry, not 2.1. If I multiply 3.279 times 21.3, it's going to be way too big. Times 23, way too big. Maybe 4.3, but this also is going to be too big. 4.3 meters times 3.279 feet per 1 meter. The meters fall out. Go ahead and multiply this out. 4.3 times 3.279, and I'm going to get 14, way too big. So approximately 14 feet, nope, that's way too big. So it's going to be A. It's almost 7 feet. Okay, you're checking this set of numbers that are proportional here. You're looking at all these proportions. And all right, which set of numbers? Okay, number 8, which set of numbers is proportional? If I'm looking for proportional numbers, I might go hats to student instead of students per hat, because one student might have multiple hats, but 2 students aren't going to share 1 hat, right? You can't put your head in the same hat. That seems silly. But so same with cell phones per student, chaperones per student, computers per student, even though this one's on top. Just think of it that way. But let's look at the proportion. This is 1 to 1, then 1 to 2, then 2 to 3, 3 to 4. These aren't all proportional. I can tell that just by looking at it. 1 to 1 is not the same as 1 to 2, or 2 to 3. Or 3 to 4. So not that one. 1 to 1, 1 to 2 are already not the same proportions. 2 to 20, 2 to 30, not the same proportions already. Let's look here. 1 to 2, that's 1/2. 2 to 4, well, that reduces to 1/2. 3 to 6, well, that also reduces to 1/2. 6 to 12, well, that also reduces to 1/2. So ding, 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 these are all 1/2. And this one would be a set of numbers that's proportional. Okay, number 9. The number of cars moved from one parking lot to another is proportional to time in minutes. The graph shows the relationship, which is time to cars. So this would be X, time is X, and cars is Y. Which of the following represents the constant of proportionality? So remember that constant of proportionality is going to be your Y to your X, okay? Y to X, because they said the number of cars moved from one parking lot to another, so number of cars is your Y, that's number of cars, is proportional to the time, that was your X. So the number of cars to the time was your Y to your X. So let's go ahead and find a point. where we can figure it out. Which of the following represents the constant of proportionality? So we want to find a point on the y and a point on the x. Now right here, this dot isn't right on the 1, 1 mark. It's a little below. So we need to find one right on a whole number. That will make it easier. And we can see there's a 3 here and a 4 here. So this is 4 for the x, and you go up 3 for the y. So the constant, remember, is the y to the x. So we would have 3 cars for every 4 minutes. 3 cars for every 4 minutes. And that would be it. Okay, so number 10, at the grocery store, 3 cans of tuna fish are on sale for $1.08. Which equation could be used to find the total cost, C, if a customer wants to buy 7 cans of tuna? So if we know 3 cans are on sale for $1.08, we're going to take our $1.08, that's how much we have, and divide it by 3, because that will tell me how much I'm paying per can. So $1.08 and divide it by 3, and I'm paying 0.36 or 36 cents for a can of tuna. All right. Now, if I want to buy 7 cans of tuna, and I know they're 36 cents a can, I'm just going to say the cost is 7 times 0.36, and that's all I have to do. So first, figure out that unit rate, what it costs for 1 can. So I took the total amount, divided by the number of cans. It was 36 cents. And then set up your equation. There are 7 cans times 36 cents, and that's all you have to do. All right, number 11. What value of x makes x over 3 equals to 1.2 over 4, a proportion? So basically, I just need to solve for x, and I can do that by cross multiplying. All right, this is how I can solve this proportion. So I'm going to go x times 4 equals 3 times 1.2. Now I'm going to do this part on a calculator. I'm just going to go 1.2 times 3, and that will give me 3.6. That equals x times 4, and I like to write that as 4x. It's easier. Now to solve for x, I divide both sides by 4. X is multiplied by 4, divide, that's the opposite. Bring down the x, bring down the equal sign, and then do the math here. 3.6 divided by 4 is 0.9. So 0.9 or D would be the answer. Okay, number 12 says a chili recipe calls for 6 pounds of ground beef for 25 servings. So I'm going to write this as 6 pounds per 25 servings. Okay. How many pounds of ground beef are needed for 30 servings? So I can set up a proportion, and if I don't even have to reduce this, I could reduce this to a unit rate and then multiply by 30. Or I could just go 6 pounds to 25 servings equals how many pounds for 30 servings? Pounds to servings, pounds to servings. And you cross multiply and solve. 6 times 30, well 6 times 3 is 18, add a 0. So 180 equals 25 times x. Now 25 is multiplied by x, so to solve for x, I do the opposite, which is divide. Divide both sides by 25. I'm going to get x equals, what's 180 divided by 25? That is 7.2. 7.2 pounds for 30 servings, and it's B. Okay, Audrey used a scale. 1 inch is 5 feet to construct a scale model of the school gymnasium. So a basketball hoop in that model has a height of 2 inches. What's the actual height of the basketball hoop? So looking at the little model, the basketball hoop is only 2 inches. If 1 inch is 5 feet and the basketball hoop was 2 inches, well, you just multiply by 5 and you get 10 feet. Simple enough. And that's your answer. Now, if you wanted to set up 1 inch is to 5 feet, and then you could say you would say 2 inches is how many feet and set up a proportion. You could do that, but really this one's so simple you don't need to. And you would cross multiply, you would get x equals 5 times 2, which is 10, and you would get the same answer. Okay, a model of a commercial airplane. Okay, this one is, there's a model of a commercial airplane. It's 11.5 inches long. The actual length of the airplane is 230 feet. And they just want us to make the scale. So if 11.5 inches is actually 230 feet, We just need to reduce this to a unit rate. I'm not going to make it in feet. I'm going to make it in inches. 1 inch is how many feet? So I'm not going to divide both by 230 because I don't want it to be in feet. That's the actual thing. I want it to be in inches. So I'm going to divide both by 11.5. 11.5 divided by 11.5 is 1 inch. And then 230 divided by 11.5 is actually 20. That's a beautiful number. So 1 inch is 20 feet. And there you go. All right, let's look at the next one. Okay, so for 15, we're going to use similar triangles ABC and FGH. If they're similar triangles, all the angles are congruent and the sides are proportional. We want to know which segment corresponds to BC. So here's BC. Which segment corresponds to it? Well, look at the angle markings. There's the one angle marking, meaning angle A is congruent to angle F. This has a 3 angle marking showing C is congruent to this 3 angle marking, and that has a 2 angle marking showing it's congruent to G. So I want BC, so I'm going to go to the 2 marking to the 3 marking. I'm going to come over here to the 2 marking to the 3 marking. Now these ones line up nicely, but if the triangle is rotated, you should be able to figure it out that way. All right. So I want to know BC. Well, it's going to be corresponding to GH or HG. Okay, so BC corresponds to GH. You can call it HG if you so choose. All right. Which angle is congruent to angle G? Here's angle G. It has the 2 markings, so you look for the other 2 marking, and it's right here at B. So that would be B. That one is your congruent angle. All right, let's look at 17. At the same time, a 15-foot pole casts a 7.5-foot shadow. A nearby tree casts an 11-foot shadow. How tall is the tree? Well, if you have a 15-foot pole, let me see if I can draw that a little straighter. You got a 15-foot pole, and it casts a shadow that is about 7.5 feet. Okay, and here's your 15-foot pole. Draw a picture for stuff like this. Always draw a picture. Now you have a nearby tree, so some tree, and it's casting an 11-foot shadow. So draw a longer shadow here, and a tree is obviously going to be taller than the pole if its shadow is bigger. It's the same time of day, so that doesn't matter because it's exactly the same time. So go ahead and set up a proportion. Similar figures here. We're going to assume these are right angles because they're going to be perpendicular to the ground. So I'm just going to go 15 feet is to how tall the tree is. 15 feet is to X. As if I start here with this triangle and I go here to this triangle, once again I start here with this triangle or this perpendicular line, I'm going to go 7.5 feet to 11 feet. And I didn't actually make them triangles, but you can make them right triangles if you want. Like that. All right, so let's go ahead and solve this proportion. I'm going to cross multiply. And I'm going to go 15 feet times 11 feet. And if I go 15 times 11, I'm going to get, let's see, 165. Now, if I did feet and feet, I actually get feet squared if you want to keep your units and be accurate. And then X times 7.5 feet will be 7.5 feet times X. Now to solve this, I just divide both sides by 7.5 feet. Divide both sides by 7.5 feet. Now the feet squared and the feet fall out, and you're left with just feet. So this cancels out, and over here, I'm going to write it up here, you're left with X on this side equals 165 divided by 7.5 is 22. And then feet squared divided by feet, just leave you with feet. So if you want to be accurate with your units, that's how you do it. If the units mess you up, so it would be 22 feet. If the units mess you up and you can see you're going to end up with the right units, you can go ahead and do that whole thing without the feet there if that's confusing you, and you can see, well, I'm going to do feet squared and then it's just going to leave me with feet. That's fine. Just drop them. You would just set it up like this. 15 is to X as 7.5 is to 11. And then cross multiply, and you're going to get the same thing. X, or 15 times 11, you're going to go 165, and that equals x times 7.5. And then divide both sides by 7.5. And then you come up here and you'd be left with x equals 165 divided by 7.5 is 22, and then you would know that's in feet. All right. All right, the cost of paper towels is $8 for 5 rolls, or $14.40 for 9 rolls, or $19.20 for 12 rolls. How many paper towels do you want? Let's go ahead and look. They want to first, what method can I use to determine whether the cost is proportional to the number of rolls? And if it is proportional, find the constant of proportionality. What is it? So constant meaning just divide them out, find that unit rate. Okay. What method can we use? Well, the method I can use is find the unit rate for each proportion. So hard to write with this, and I apologize for the really messy writing. 2, let's do it. Find the unit rate for each. It's $8 for 5 rolls. What is that? I'm going to take $8 and divide it by 5, and I'm going to get 1.6. Then I could do $14.40 for 9 rolls. So go 14.4, divide it by 9. Oh, look, it's 1.6. It's working. Let's see if that one works. $19.20 for 12 rolls. So divide that by 12, and I'm going to get 1.6. So yes, they are proportional, and the constant of proportionality, or the unit rate, is 1.6. All right, this is actually useful when you go to buy things like, say, at Walmart or Costco. And usually when you buy the bigger bulk, you get a cheaper deal. Like this might be $15 if you buy 12 rolls, but sometimes it's not. So it's good to figure out the unit rate. I've seen it where it's actually more expensive to buy the bigger bulky thing, which is crazy. But usually when you buy 5 rolls, you pay a little more. And when you buy 12 rolls, you pay a little less. That's why you buy more, but not here. They're all the same. All right, on to the last one. The directions on the bag of fertilizer indicate that 1 bag is enough to fertilize half an acre. So, part 1, we need to explain how a farmer could find the number of bags of fertilizer he would need for 42 acres. Well, he could just use solve a proportion or use the unit rate. Use the unit rate, which you're already given. 1 bag fertilizes a half an acre. And we need to know how many bags for 42 acres. You could use the unit rate, or you could set up a proportion. Okay, that's what you would do. Part 2, it wants us to write an equation that would find the number of bags he would need for 42 acres. So let's go ahead and set up a proportion. We know 1 bag fertilizes a half an acre. So we want to know how many bags fertilize 42 acres. So I did that, and then part 3 I'm going to solve. Cross multiply. 1 times 42 is 42. 0.5 times x is 0.5x. Now I'm going to solve this. I'm going to push it up here. 42 equals 0.5x. Divide both sides by 0.5. That eliminates that. I'm going to go 42 and divide it by 0.5, and it's going to give me 84. And that's what x is. And think about it, see if that makes sense. If 1 bag covers a half an acre, how many bags would you need for 42 acres? Well, 1 bag covers half an acre, so 2 bags would cover a whole acre. So basically you need to double it. So if I need 42 acres, I need 84 bags, right? And that's how you do it, folks. Let me know if you have any questions, and have a good day.